It's a little before 9 p.m. Eastern Daylight Time on the evening of Sunday, March 29th, 2020. I'm using my Nikon D3200 camera attached to a 3.5-inch Questar telescope. I have this telescope focused right now on the bright star Sirius. It's the brightest star in our sky, and I have it a pretty good focus. The seeing is pretty bad tonight, so it may not be a great focus, but the best I can do on a night like tonight. And you'll see it's a little tiny dot, not very large at all. That's how you know when a star is properly focused. Now I'm going to take it out of focus, and as it does, the image of the star will get bigger, but it's an out of focused image. And notice it gets pretty far out, at least on the Questar, it turns into a donut. The reason for that is there's a central obstruction that's called the secondary mirror, and just about every reflecting telescope has a secondary mirror, and that secondary mirror produces a shadow when you take it way out of focus. You always get a donut shape when that happens. On a refractor, you're not going to get that because they don't have a central obstruction, and on a camera lens, you're not going to get that. Notice the thing's kind of undulating and rippling. People, flat-earthers like to think that is the water above the firmament or something. No, that's simply bad seeing. It's turbulence in the atmosphere. It's what causes stars to twinkle. As I'm looking at Sirius with a naked eye, I can see it twinkling just a little bit. The telescope, it could be accentuated quite a bit. Again, that is an out-of-focused image. You can tell by looking at it that it's just way too big. So if I take it back into focus, it will be a little tiny dot. Notice that donut will a hole in the donut will disappear because you're getting close to focus. Only when you're pretty far off will you get that donut. Now I'm going to go past the focus in the other direction, and I think this is probably too close and the other one's too far. And you can see again the donut shape. No matter which side of the focus I go on, you're going to get a big blob, a little big disc, and that's what the problem is. A lot of flat earthers are looking at that and thinking that they're seeing a big star, and they're not. They're seeing an out of focus star. I'll get the focus pretty good there. And what I'm going to do is I'm going to move over to Venus. Now, I'm not going to change anything on the camera or anything else. I'm just going to move the telescope. It'll take me a moment to do that, so please bear with me as I do this. I'm afraid I might have to refocus to even find the thing. So hold on a second. Unfortunately, I will have to do that. Wait a minute. I might have it in. There we go. It's slightly out of focus, I think. Let me get it back in to focus. Now notice I can't get it down to a small dot like Sirius was. And there's a little crescent sort of shape. If I take a still from this and magnify it, it'll look fairly decent. That's about as small as I can get it. And it's that little pinpoint, it's a little half moon sort of shape. Now, let me take it out of focus and watch what happens. It gets larger. And as it does, it becomes a big disc. And there's a dark spot in the middle again. This tells me it's way out of focus. As I make it smaller and smaller and smaller, then it becomes more of a dot, a little tiny thing. But again, it doesn't go all the way down because it is a planet. It has physical extent, probably 30, 40 arc seconds, and a star is many orders of magnitude less than that. It's about as good as I'm going to get Venus tonight down there. It's going to look like a little tiny crescent when I get it focused best. Again, that's in focus. This is way out of focus, and this is way out of focus. People with the P900, P1000 cameras, you need to learn how to focus. The smallest you can make objects, the more in focus they are.